Welcome to Study Loop.
Okay, folks, so in this video, we're going to be talking about this problem. Physicist S. I'm sorry, I can't pronounce his name. This guy devised a method for measuring the mass of heavy ions by timing their period of revolution in a known magnetic field. So a singly charged ion of iodine makes 7 revolutions in a 45 mt field in 1.29 milliseconds. Calculate its mass in atomic mass units. Okay, so this problem is not necessarily, conceptually speaking, difficult to understand. So before we get started doing it, let's just see if we can conceptually understand it, right? Because I think that's the most important thing. It you have If you have a charged particle moving in a magnetic field, it's going to be deflected. It's going to be swirling around. So, for example, if your B field, your magnetic field points into the page, right? And then you have a either positively charged or a negatively charged particle moving in this region. Now, this is your particle. It's not just going to move straight in a straight line, right? If it's already moving with a velocity in vacuum, then it's going to keep moving in a straight line. But since this is not a vacuum, this is it's not moving in a vacuum, it's moving in a magnetic field. What it's going to do is that it's not going to keep its straight path. It's going to start whirling around in a circular motion, right? So we can find out a lot about this particle given the fact that it's moving in a circular motion. So here's what I mean by that. We know from Newton's second law that mass times acceleration equals the force, right? What is the acceleration of a particle that is moving circularly? It is v squared over r. Now, on the other hand, what is the force on this particle? It is the magnetic force, right? So it depends on Q. It also depends on V cross B, but we're just gonna assume that V and B are perpendicular because that's how you make the particle whirl around. So V cross B is just gonna give you magnitude of V times the magnitude of B with a sine theta, which I'm going to ignore because they're perpendicular. Okay, so let's simplify this. V and V squared, you can cross out one of the V's. So you're left with mv over r equals qb. What we're looking for is we're looking for the mass, right? What do we know? Do we know the charge? Well, we actually do, because in this problem what we have is a singly charged ion, right? What does it mean for a particle, for an ion to be singly charged? It means one electron has been ripped off of it, right? If that electron was not ripped off of it, then this thing wouldn't be called an ion. The fact that it's singly charged means one electron has been ripped off of it, so it's charged, and that Q is equal to the charge of an electron, right? So that Q is equal to the charge of an electron, or the charge of a proton, because the magnitude of both are the same. Okay, so we do know the charge. Do we know about the B field? We actually do as well. The B field is a 45 mt field. So the unit is mt instead of t, but whatever. So we do know the magnitude of the B field. It is 45.0 mt, and it's a constant. So we know Q, we know B. Do we know about the radius? Well, I don't think we do. But do we know about the velocity? Well, we don't know that either. So how are we going to do this? Well, in order to do this, let's recall that the period of a particle that is moving in a circular motion is going to be the total distance that it travels in a circle divided by its velocity. And its velocity is just v, and what is the total distance that it travels in a circle? Well, of course, it's just the circumference, which is 2 pi r, right? So we have this thing. We have r over v equals t over 2 pi, right? That means v over r equals 2 pi over t. But 1 over t is just frequency, right? So v over r equals 2 pi times the frequency. Do we know the frequency? Well, we do, because it makes 7 revolutions in 1.29 milliseconds. So that's the frequency. That gives us the frequency. The frequency is 7 revolutions per 1.29 milliseconds. That gives you the frequency. Okay, so we can plug this frequency back into this equation. So we have mv over r equals charge times b. That means m equals r over v times charge times b. Alright, this is equal to, what is r over v? It is 1 over 2 pi frequency, because v over r is 2 pi frequency. R over v is the inverse of that. It is 1 over 2 pi frequency. Now we're done. This is the mass. We know the charge. We know the b field. We know pi. It is 3.14 something. And we know the frequency. The frequency is here, 7 divided by 1.29 milliseconds. And if you gather all of these numbers, these constants, and plug in all of them into your calculator will give you the answer. And that answer, if you convert that answer from kilograms or whatever other units into atomic mass units, you will find that the mass is 127 atomic mass units. Okay, so this is the answer to this problem. Thank you very much. See you in the next video.